Hello and welcome back. Now in this tutorial, I'm going to develop the delete operations for a doubly linked list data structure. We'll be developing the delete first, delete last, and delete target operations. The delete first function is going to delete the first node of the linked list if that exists. The delete last is going to delete the last node of the linked list, obviously if that exists. And also the delete target is going to delete the node that contains the target node if the target found in the linked list. So let us first do the delete first operation. The first thing that we need to check in the delete first operation is that if there is any node, at least a single node in the linked list. So we can just check the node count. So lstptr arrow node count. If that is 0, then we can just return 0 to the caller because no node exists in the linked list. So there is no question of deleting the first node. And we are returning 0 because the delete first operation failed. Okay, now if there are nodes, there can be two situations. Case 1 is that there is only one node in the linked list and we need to delete that node because that's the first node and that's the last node. And you can see that there in the image. I have the image there. It is under case 1. This is the only node that we have there in the linked list. So in that case, both the head and the tail pointer has to be assigned with null. Currently, both head and tail are pointing to the first node and the last node, the only node. So if we are going to delete this node, then we need to just assign null to both head and tail pointers. So what I'm going to do here, I will just take a node pointer and I'll just assign the address of the first node to that node pointer. That's the first thing that I'll do. So p equals head. Node pointer p equals head will actually assign the node pointer p to the first node. That means p is right now 1000 and p is pointing to this first node. Okay, now if there is only one node, then we can just go ahead and assign null to the head and tail pointers. So if lstptr arrow node count, if that is equals with 1, then we have only one node there in the linked list. And lstptr arrow head equals lstptr arrow tail equals, that should be null, right? Otherwise, if there are many nodes, the case 2, that's case 2. Okay, so this is the case. We have many nodes here and we need to delete this first node. So p is right now pointing to this first node as we have assigned here. Okay, so p is right now 1000, and if we need to delete this first node, what we need to do is to move the head to the second node. So we should move the head pointer to the second node because we are going to delete the first node and the second node is going to become the first node in that case. And what next we'll be doing is that we'll just assign null to this previous pointer. This pointer has to be assigned null because this node is going to become the first node. So the previous to this node should be null. Okay, so let me do that. So here we go. So lstptr arrow head, that should be moved to the next node. lstptr arrow head arrow next, that will take the head to the next node, and then we need to assign the previous pointer with null. So lstptr arrow head arrow prev, that should be null. So we are done with this. Now the last thing that we need to do is to free the node pointed by p. That's the first node. That was the first node actually. Right now we need to free that just to return the space back to the free store, and we need to decrement the node count by 1. So lstptr arrow node count should be decremented by 1, and since we have deleted the node successfully, so we can just return 1. So that's how we can just do the delete first operation, and the delete last operation is actually going to be symmetric with delete first operation. Okay, let's do the delete last operation. The first condition is just same. If we do not have any node there in the linked list, we cannot delete the last node, so we are just returning 0 in that case. And we have the pointer p as usual, but this time this pointer p is pointing to the last node of the linked list. As you can see that we have assigned tail to p, and if there is only one node and we need to delete that one, because that's the last node. So in that case, we'll assign head and tail both with null, as we did exactly in case of delete first. So I can just copy this code there from there. So I'll just copy that. Okay. So if there is only one node, we are just assigning null to both head and tail pointers. Otherwise, if there are many nodes, then we need to delete the last node in that case. So for that thing, we need to move the tail pointer to the previous node, that second last node. So we can just write this code, lstptr arrow tail. That should be actually, that should go to the previous, to the last node. So lstptr arrow tail arrow prev, and you can get the previous node's address by using the prev. That's the facility of this doubly linked list. And we need to assign null to the next field of the last node. So the current last node is now the second last node, that the tail has been moved to the second last node right now. So lstptr arrow tail arrow next, that should be actually null, because this is going to become the last node. And we are done with this. We need to just free the node pointed by p, just to return back the allocated space to the free store, and then decrement the node count by 1, lstptr arrow node count minus minus. And since we have deleted the node successfully, we are just returning 1 to the caller. So that's how we can delete the last node. So both of these delete first and delete last operation are useful for building the double-ended queue that we'll be doing next to this section, where we'll be using this delete first and delete last operation along with the insert first and insert last, or add first and add last. We'll see how we can do that in the next section. But before doing that, we just need to implement this delete target. Now this delete target is going to delete the node that contains the target data. Okay, so first of all, what we need to do is to just find the target node there, if that exists. So we can just call the find operation. We have written that find operation earlier. So we just need to transfer that lstptr to the find operation and the target. So if the find operation returns null, if p equals null, that means the target does not exist. In that case, we are just returning 0 to the caller. Oops. Okay, simple printing mistake. Anyway, so if the node containing the target does not exist, I mean if the target is not there in the linked list, we just return 0 to the caller. Otherwise, if the node is there, then we can just delete that node. Let me just explain the situation by drawing an image there. Now this can be the first node, the target node can be the first node, or can be the last node, or can be any node in between, right? So if that's the first node or last node, then we can just make a call to the add delete first or delete last. So say if the target is this one, if p is this one, then we can just make a call to the delete first operation. Or if the p is the last node, we can make a call to the delete last operation. So let us do that first. So if p is equals with head, then we can just make a call to the delete first, and whatever the delete first returns will return back to the caller. So delete first lstptr, and whatever the delete first returns, either 1 or 0, will be returning that to the caller. Now if p is tail, then we need to call the delete last, because the last node is the target node that you want to delete. So delete last, and we are passing that lstptr to that delete last. And otherwise else, that means it's any node in between the first and the last node. That's our target. Say in this example, in our image, this is the node that we intend to delete. Now if we want to delete this node pointed by p, then the previous to this p should point to the next to p, and the next to the p should point the previous to p. So we can just do this using this code. It's going to be a little bit tricky, but not so much tough to understand. So p arrow next arrow prev, that should actually point to the p arrow prev. I'll explain that, no problem. And p arrow prev arrow next, that should actually point to p arrow next. So let me explain that. And one more thing that we need to do is to free that p after doing this, and lstptr should be decremented. lstptr arrow node count should be decremented. So minus minus. Let me explain what I did there. It may be a little bit tricky at first glance, but not so much tough as I said. So you can see that p arrow next, that means it is actually referring to this node. This is actually p arrow next. If p is this one, then p arrow next is just the next node to that. Okay, so now arrow prev means p arrow next arrow prev means we are actually referring this particular pointer. Let me change the color there. Okay, so we are referring this particular pointer there. And what is that assigned with? That is assigned with p arrow prev. P arrow prev is right now the content of this pointer. And if this is 1000, we have 1000 here, right? So that 1000 is actually copied here. So this particular pointer is now pointing to this node, the previous node to p. Because we are going to delete this node, so this node should point to the previous to p. And similarly, p arrow prev arrow next. That means p arrow prev is this node, p arrow prev. If p is this one, then p arrow prev is this one. And p arrow prev arrow next, that means we are referring to this particular pointer here. That should point to the next to p. So we are assigning the p arrow next there. So if the p arrow next, say this is 3000, then p arrow next here we have 3000. So that is actually copied there in the next pointer to p arrow prev. So this is now pointing to this one. So that's how we can just delete any node in between the first and then the last node. So I have added all the calls to these operations there in the main. So I'll show you how they work. So let's go ahead and compile this. Let me show you the call from the main function. They are straightforward, as we did in case of insert after, insert before, something like that. So you can see that case 11 is delete first, and we are actually calling that delete first from here. And if the delete first is returning 1, we are just printing a success message. Otherwise we are printing a failure message. Similarly, we are just calling the delete last, and in the same way we are printing the success and failure message. And otherwise, if case 13 is actually used by the user, then we are just getting the target, what the user wants to delete, using the scanf, and then passing that target here in the delete target call. And if that returns 1, we are just printing the success message, otherwise printing the failure message. So that's how we can just do this. Okay, let's now go ahead and try to compile this and run this and see how this delete operation works. Okay, keep watching. Okay, it seems that I have developed a habit of doing the same mistake again and again. You see that I have used head again here, but head is not there. It's there in the object, linked list object, and the pointer to that object is lstptr. So it should be lstptr arrowhead, and again I have the same mistake here. It should be lstptr arrow tail, and then we have the same mistake here at line 436, lstptr arrow tail, and then we have it here as well. Okay, so we are done correcting these things, and we can just go ahead. You can see that I tried to compile, and that gave me all those errors saying that it is the tail is undeclared or the head is undeclared. Let me just compile once more, dpl list.c. Okay, it is actually having an error of not returning the values. Let me see that where it's giving 464. Okay, so it is actually having it here because we have not returned the value from this else part. Okay, we must return 1 because we have successfully deleted the node, so we should return 1 from there. Now we can just go ahead and compile once more. It has been compiled, and we can run this right now. So I'll just generate the linked list. I'll create the linked list, and I'll just create 5 nodes there. So let me just display that. Okay, we have that linked list there, and I'll just call the delete first operation, that's option 11, and I'll see again if that has been deleted. So 267 was the first node, and you can see that 267 is not there after the delete first operation. Now I'll just call the delete last operation, that's option 12. Okay, so again I'm going to display the linked list. Yes, 180 is not there. Now I'll call option 13, delete a target node 717. Okay, and that has been deleted, so we can just check. Yes, 717 is not there. So I think you can just go ahead with this and check if all the delete operations are working fine, or if all other operations are working fine with your program or not. So that's all for developing the operations for double linked list, and next we are going to develop a double-ended queue using these operations, and nothing is going to be new there. Okay, only we'll be using the add first, add last, delete first, and delete last in order to build the double-ended queue, and that's going to be really simple. And after that we'll just go ahead with circular linked list. Thank you very much for watching.